All right, so question 7 asks, assume that a patient's systolic blood pressure is normally distributed with a mean of 150 and a standard deviation of 8. Find the probability that a single measurement of his or her systolic blood pressure is 160 or higher. All right, so since we're doing normal distributions and we want to see the probability, first, let's put that down. Probability that a measurement we take is greater than or equal to 160. Now we want to change this into a z-score probability because this is a normal distribution. So probability that z is greater than or equal to 160 minus 150 over the standard deviation, which is 8. All right, so that's going to be the probability that z is greater than or equal to 10/8, which is 1.25. All right, now to read this on a z-score table, we need to flip this inequality sign and do that. We just subtract the inequality sign flipped from 1, so 1 minus the probability that z is less than or equal to 1.25. All right, and then we just find that on our z table. 1.25 will be 0.89435. 0.89435. All right, and then 1, subtract that from 1 would give us 1 minus 0.89435. That equals 0.10565. All right. And then part B asks, the patient's systolic blood pressure is measured 9 times at different times during a day. Find the probability that the average is 160 or higher. All right, so from my understanding, this will be a, what is it? The sampling distribution of a sample mean. So basically we'll do the same probability, let's call this y since it's a different variable we're looking at, 160. And when we turn this into a z-score, we're going to divide it by the square root of our sample size. So 160 minus 150 divided by 8 divided by the square root of 9, which is our sample size. This ends up, oh, sorry, not y here, z here, because we're turning into a z-score. All right, and if we do this calculation, it would be 10 divided by 8 divided by 3, which is 3.75. So the probability that z is greater than or equal to 3.75. All right, and then changing this, so we flip the sign around, it's 1 minus the probability of z is less than or equal to 3.75. And on our table, we can find 3.75 as so 1 minus 0.99991, and that equals 1 minus 0.99991. One, two, three, four. There. Yep. All right. So that's question number 7. Like I said, from my understanding, that's where this problem is headed, but I could be wrong in it.